Can a black hole also shine? Well, we'll see that at the end of this video. A galaxy rotates about what is called a galactic nucleus. This galactic nucleus has a supermassive black hole, which has an enormous gravitational pull. The galactic nuclei can either be active or inactive. By being active, it means that the supermassive black hole is devouring the material around it. In this process, it emits radiations across the electromagnetic spectrum, making it glow very brightly. But in case of an inactive galactic center, there is no such brightness. In our galaxy, the Milky Way, the galactic center is not active. The supermassive black hole in the center of our galaxy, called the Sagittarius A, is not active and is not consuming any material, and hence is not producing any brightness around it. This theory of active and inactive galactic nucleus provided clarity about the confusion prevalent in earlier times when astronomers used to see very bright star-like objects which used to have very strange spectral lines. Now we know that this is an active galactic nucleus with a supermassive black hole at the center, devouring the gases and dust and emitting light so bright that the entire galaxy could not be seen, and it appeared like a point star. Having understood this, let us now look at what a blazar and a quasar is. An active galactic nucleus will be referred to as an AGN in short. Inside of an AGN, a supermassive black hole has a mass ranging from millions to tens of billions of a sun and is surrounded by a gaseous disk. Gas in the disk falling towards the black hole heats up because of friction and releases energy in the form of electromagnetic radiation. It is because of this radiation that it emits luminosity thousands of times greater than other galaxies like the Milky Way. Attracted by an enormous gravity, most of the matter falls towards the central black hole as it feeds on the gas and the dust. But a small amount of particles get accelerated to almost the speed of light and escape the black hole along its axis of rotation in two narrow beams perpendicular to the galaxy. These beams are called relativistic jets or cosmic rays. They are composed of ionized particles or plasma, and their lengths can reach several thousand or even hundreds of thousands of light years. It is interesting to note that the brightness of the disk and these jets can vary based on from where we are seeing them. This effect is known as relativistic boosting, similar to the Doppler effect for sound waves. When the X-rays traveling at about the speed of light around the outer layer of the black hole approach the observer, they appear to be more bright, as you can see in the left side of this black hole, whereas if they are going away, they appear to be dim. These bright X-rays can then shift toward the center from the outer layer of the black hole, creating the jets or the black hole X-ray flares. Now, having understood about a relativistic jet, we can now distinguish between what a blazar and a quasar is. When galaxies with AGNs emit relativistic jets straightly at the observer, the galaxies appear to be very bright spot-like objects. This is what we call as a blazar. And if the relativistic jets are at an angle towards the observer and not straight to him, we call this as a quasar. If the relativistic jets are exactly at 90 degrees to the observer, we call the galaxy a radio galaxy. Hence we can say that all the three are same kinds of galaxies with an active galactic nucleus at the center emitting relativistic jets, but the naming depends on the angle at which we see them. An interesting fact is that our Milky Way galaxy is expected to have a galactic collision with the closest Andromeda galaxy in about 4.5 billion years, which will result in the creation of a supermassive black hole with an active galactic nucleus. The significance of a quasar and a blazar is that by finding its existence, we now know that a supermassive black hole exists at the center of all the young galaxies. Quasars helped the astronomers understand the working of the universe. They showed us how far they actually were, and it gave us a rough idea as to how large the universe truly is. As of now, in 2023, closest quasar to Earth is the Markarian 231, which is located 581 million light years away. So mind you, when you hear the twinkle twinkle little star the next time, thinking that only a star can twinkle, remember that there is an enormous white black hole emitting huge amounts of energy, shining way more brighter than a star, millions of light years away. Don't forget to like, share and sub for more such awesome content only on Naichis.